Connect from output one of the Unit 48 processor to a monitor speaker. Its signal is fed in from input A. Next, open the VOS software. Solo the Alt1 channel, mute the other channels. Next, play pink noise to measure the curve of this monitor speaker. Then insert delay and save. Name it Monitor. Open the latest version of FIR software. Then click the drop-down menu here. Find the currently measured monitor curve. These two softwares will automatically connect together. That is to say, the VOS software will communicate with the FIR software. No need to export and import anymore. Next, click the FIR button here. We will perform FIR processing on the current curve. First, we need to select a target curve. Select Monitor. Because this is a monitor, right? Close this window. The target curve is already displayed in the image. Next, determine a frequency range. We decide to start processing from 100 Hz. Check the amplitude box here. Then enter 100 for the start frequency. That is, automatically process this amplitude. From 100 Hz to 20,000 Hz. Next, the phase is the same. From 100 Hz to 20,000 Hz. Click FIR Export. Here you can select its sample rate. The processor we are currently using is 96K sample rate, and the maximum supported order is 512. Temporarily close this window. Light up the result. You can see, the final result of the processing here is this pink curve. Click FIR Export again. Then directly click FIR File Export. Then put it on the desktop. Give it a name. Then click Save. Okay, let's temporarily close these windows. Now let's go back to the processor interface. Then double-click to enter the Alt1 channel. Click Import here in FIR. Find the file we just exported. Open and light up the FIR master switch. Then you can check the amplitude of FIR processing here, just like EQ, right? And its phase. Because the phase has been processed, it will definitely have delay. Okay, next, we use VOS software to measure. Insert delay, amplitude curve, and phase. The curve becomes very flat, meeting our expected result for the target curve. Save the curve. Pause playback. You can see that the delay last time was 4.15, and this time the delay is 7.48. Their delay difference is 3.33 milliseconds. Doing FIR adds an extra 3.33 milliseconds of delay. This is because we processed the phase. Go back to Auto FIR again. Uncheck the phase box. Then click Export again. Next, we can see the diagram above. The left half of it has become a straight line. The front part of the impulse response is no longer processed. Close this window. Check the phase box again. Then go back to FIR Export. You can see, the leading edge of the pulse peak has changed. Then we uncheck the phase box again. Take another look. The leading edge of the pulse peak becomes a straight line. We enter a 0 here. That means we move the pulse peak to the 0 scale position of the time window. It also means 0 delay output. Because no processing is done before the pulse peak, the frequency response will not be affected. If we check the phase box at this time, you can see, the amplitude response becomes bumpy. So once the phase is processed, it will definitely bring delay. Next, we still uncheck the phase box. Let it become a flat line. Then we export with 0 delay. Put it on the desktop. Name and save. Go back to the Unit 48 processor. Clear FIR and then import the just saved file again. Measure again. Find that the FIR master switch is not turned on. Now turn it on and insert delay. Save the curve. Pause playback. Obviously this time the phase curve is no longer flat, but we can see its delay is much smaller than before. It's 4.81, while the earliest test was 4.15. So in fact, the delay has also increased a little bit. Okay, thank you all for watching. See you next time.